Hello. This is the next series of our talk on photochemical reactions of organic compounds. We have started the last two terms. We have been discussing about the photochemistry of carbonyl compounds, which I mentioned earlier that these the aliphatic carbon compounds as well as alicyclic carbon compounds undergo characteristic Norrish type 1 reaction. Norrish type 1 reaction is nothing but alpha bond cleavage, and we have discussed few examples last lecture, and this lecture also we would like to look into few more examples on Norrish type 1 reaction of alicyclic ketones. One of the most important aspect in these reactions are if the alpha carbon is substituted, then we talk of alicyclic ketones. So it is say for example, this is our carbonyl compound, and then this Norrish type 1 reaction is one of the most common reaction in these compounds, which involves alpha bond cleavage. So we have this is also alpha bond as well as this is also alpha bond. So when it is when alpha carbon, this is your alpha carbon, this is also alpha carbon. So if the alpha carbons are unsubstituted and when it is symmetrical, then we can cleave any of these. If we cleave this or this, it leads to the similar carbon atom, carbon radicals. But if the carbon compounds alpha carbon is substituted, then there will be a preferential cleavage and preferential in such a way that, say for example, if we consider this, and if this carbon is substituted with dimethyl group, then if we cleave this, we end up with a tertiary radical, or if we cleave this, we end up with a primary radical. So when we talk of the stability of this, we know that the tertiary radical is more stable than primary radical. So tertiary radical, this will be a preferential cleavage. That's what we have looked into. We have also looked into a few more examples. Say for example, we have looked into the examples like this and so on. We also mentioned that the radical on the cyclopropane ring is unstable. Radical on the double bond is less stable, and hence the other cleavage will be preferred, but the radical adjacent to the carbon to the cyclopropane is stable. The radical adjacent to the double bond is, so this is going to be preferential cleavage. This is not this is going to be cleavage here. This is going to be a preferential cleavage to generate here. This is not, this is going to be a preferential cleavage to, because this we are going to generate radical here. All these examples we have discussed last time, and now this we did not look into, so we will just see this example today. Here we can see we have alpha, this in the photolytic condition, this undergoes type 1 reaction. This is type 1 reaction, which is nothing but alpha bond cleavage, and then this you can see, if we cleave this, we end up with a radical on the cyclopropane ring, and if we cleave this, we end up with a radical. This is a primary radical, this is a secondary radical. We know that the stability of the radical lies in the order: tertiary is more stable than secondary, is more stable than primary, is more stable than methyl radical. But we also mentioned last lecture that the radical on the cyclopropane ring is going to be destabilized, because cyclopropane is under strain and generation of a radical on the strain ring system is going to be unfavorable situation or unfavorable, and hence it is not going to be form on this one. So this radical is not going to form because we are going to generate, this cleavage is going to generate radical on the cyclopropane ring. So this is going to be a preferential cleavage, although it is a primary radical. And then this will we also mentioned that this undergoes different type of reaction, decarbonylation and beta cleavage and so on and so forth. But in these cases, in this series, we just wanted to look mainly the ring expansion product. So as far as ring expansion product is concerned, this radical will add to this radical will add to on this this radical is going to add on this carbon to generate. So this is a 5-membered ring, 5 and 3. So when oxygen is incorporated in the ring, then it's going to be a 6-membered ring, and then a carbene is going to be generated here. Carbene is going to be generated here, and then of course if we number this, so for example 1, 2, 3, 4, 5. So the carbonyl, this is 1, 2, 3, 4, and this is 5, and then this is 1 is this is 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6, right? So 1, 2, 3. So there is a cyclopropane ring between carbon number 2 and 3. And then this carbene is going to be generated on carbon number 1, and then in the presence of ethanol is going to give this this ring expansion product. We have lot of several different systems have been studied, and this Norrish type 1 reaction in cycloalkanes have been extensively studied, and we have lot of examples, and few of them we have discussed here. Few more we are going to discuss in this case. All these compounds, if you look at it very carefully, they are all bicyclic ketone, aliphatic ketones, bicyclic aliphatic ketones, and this will in the presence of photochemical condition, this will typically undergo Norrish type 1 reaction involving alpha bond cleavage. We also mentioned that whenever the alpha carbon is substituted, is going to be a preferential alpha bond cleavage to give you more centered, more stable carbon radical. Another thing which we would like, we have mentioned last time, is that the generation of a radical on the cyclopropane ring is unstable. Generation of a radical on the double bond is less stable, whereas generation of a radical adjacent to the cyclopropane is going to be stabilized. Generation of a radical adjacent to the carbon-carbon double bond is going to be stabilized. So this is very important to note over here, because first step is a photochemical step and is going to be the most crucial step in this one. And if we make any mistake in cleaving the alpha bond, then we end up with a wrong product. So all these examples are just to give a more emphasis on which alpha bond is going to be cleaved when we are talking about Norrish type 1 reaction in alicyclic ketones. So let's see one by one. We have different examples here. This 1, 2, 3, 4, 5, 6, 7, 8. So we'll just look one by one these examples. Say for example, this is the one, and then this will under photolytic condition going to undergo type 1 reaction. Type 1 reaction is nothing but is alpha bond cleavage, and when alpha carbon is substituted, you can see here this alpha carbon is substituted in methyl group. This alpha carbon is unsubstituted. There are 2 hydrogens in this carbon, and hence is going to be a preferential cleavage to give a tertiary radical. This radical is going to be more stable and going to be preferentially cleavage. And then the next step is the decarbonylation, loss of CO to give this diradical species. This diradical species can recombine to give this one of the product. Another important reaction which has been observed in this alicyclic ketone is the acyl radical abstract the adjacent hydrogen atom. So for example, this is CH3. This is CH3, and then there are 3 hydrogens in this particular case. So this acyl radical will abstract this to generate CH2 radical here. So if this acyl radical abstract hydrogen atom, and then this will form a double bond. So it generates a radical here. So I'll just see. This one, then this is CH3 here, this is a radical here, this acyl radical is going to abstract an hydrogen atom from this methyl group, then it generates a CH2 radical. CH2 radical, this is CH2, and then this becomes C double bond OH, and then this will combine to give this product. So this is aldehyde aldehydic products are also reported in these bicyclic ketones, and in addition to abstraction, instead of abstraction, this will also might abstract this hydrogen as well, and then there is a possibility of formation of double bond in this one. Of course, another important factor which may also play an important role here is the generation of double bond bridgehead carbon, and hence that is another. So in this bicyclic system, the one of the carbon is methyl substituted is going to be a preferential alpha bond cleavage under photolytic condition, which follow Norrish type 1 reaction to give you a more stable radical. This radical will undergo first route is to decarbonylate to give a diradical species will combine to give this one of the product here. Another product which is observed here is the abstraction of an hydrogen atom from adjacent methyl group by this acyl radical to generate CH2 dot, and then this will combine to form a double bond. So aldehydic compounds are also reported in this photoreaction. Now coming to the next example, this is the second example in this particular case. Here you see this will under photolytic condition, this is also an bicyclic aliphatic ketone undergo type 1 reaction which involves alpha bond cleavage, and we can see here is this alpha bond is methyl substituted, this is an unsubstituted, there are 2 hydrogens here, and then this will undergo preferential alpha bond cleavage. Preferential alpha bond cleavage will take place to give you a more stable. This is going to be a secondary radical, secondary carbon center radical. If we cleave this, we are going to generate a primary radical, and we know that the stability, more stable radical is going to form, and it will lead to the final product. So this will undergo preferential cleavage to give you this radical. This will undergo decarbonylation to give this diradical species. Since there is a cyclopropane ring in this particular case adjacent to the carbon center radical, this will open this cyclopropane, we know that is under highly strain, and it will undergo ring opening to give a this diene system and this one of the neutral product which is formed in the photoreaction of this bicyclic 5 and 3 ring system, where the alpha carbon is methyl substituted, and other there is a position the isopropyl group, another 1 to 3 position as well. So here you can see is another example of a type 1 reaction involving alpha bond cleavage, preferential alpha bond cleavage leading to the formation of a more stable carbon center radical, since there is a, and then this will undergo decarbonylation to give this as an intermediate. Since there is a cyclopropane ring adjacent to the carbon center radical, we know that the 3-membered ring is under highly strained system. It opens up opens up to give a this one of the product in this one. Going further to the next example, this is a third example in this series. As I have mentioned that just to see, the people have tried enormous systems to look at the preferential alpha bond cleavage, and also to look at the formation of different products in the Norrish type 1 reaction in the cyclic, alicyclic ketones, monocyclic as well as bicyclic ketones, and with the cyclopropane ring, just to see that how the cyclopropane ring also opens up when there is a adjacent radical is present. So this is again, you have this alpha carbon, this is also alpha carbon. If we cleave this, we are going to generate a tertiary radical. If we cleave this, we are going to generate a primary radical. The primary radical is less stable as compared to tertiary radical. Tertiary radical is going to be formed and not the, so this will also undergo preferential alpha bond cleavage. Preferential alpha bond cleavage is going to take place, and this will undergo decarbonylation. This acyl radical to give a this diradical species, as we have seen in the previous example here as well. There is a cyclopropane ring adjacent to the carbon center radical. This will also very susceptible to undergo ring cleavage to give a diene system. And of course, another example of this is very similar to this, as to just to see that whenever there is a cyclopropane ring adjacent to the carbon center radical, it opens up to release the ring stain and to get the diene as one of the major product in this type of reaction. Going further to the next example here, you see here this again this is a cyclohexanone, and then this one of the alpha carbon is substituted by a cyclopropyl group. Another alpha carbon is unsubstituted. There is the presence of a 2 hydrogen, and then this will under photolytic condition in principle undergo type 1 reaction. Type 1 reaction involves alpha bond cleavage, and when the alpha carbon is substituted, then it will undergo preferential alpha bond cleavage, and it will definitely is going to cleave here to give a radical adjacent to the cyclopropyl group. We have already mentioned radical on the cyclopropane is unstable, but the radical adjacent to the cyclopropane ring is going to be stable, because this cyclopropyl group is considered as a double bond, and it can be a additional stabilizing factor for this radical. So this moiety cyclohexanone alpha cyclopropyl substituted cyclohexanone under photolytic condition undergo preferential alpha bond cleavage to give a radical adjacent to the cyclopropane ring and more stable, and then this will undergo decarbonylation to give a diradical species. This will combine to give one of the product cyclopropentane with a cyclopropyl group as the substituent. As we have already seen in these two examples that whenever there is a radical adjacent to a cyclopropane ring opens up. Here also the radical is adjacent to cyclopropane ring, it opens up. So also in this particular case also this cyclopropane ring, this radical adjacent to cyclopropane opens up to give this diradical species, and this diradical might combine to give this ring expansion product or a macrocyclic ring system. So we started with a 6-membered ketone, and now the cyclopropyl group, cyclopropyl ring is as a substituent. Now at the end of the photoreaction, now cyclopropyl ring 3 carbons are now in this part of the ring system. Now it has a on the how many carbons? See, 6, 7, 8, 9 carbon system to give. So this is a and of course with a double bond in the 6. So this is a very interesting example where the substituent is a part of the ring system, and we started with a 6-membered ring, we ended up with a macrocyclic ring system ketone. With this example, people have also tried other example by taking 2 cyclopropyl ring. Here you can see this is a cyclohexanone, 1 cyclopropyl and another cyclopropyl. 2 cyclopropyl rings are as a substituent. Now let us see what is, and then under photolytic condition we in principle this is a alicyclic ketone, a 6-membered ketone, cyclohexanone, and of course 2 cyclopropyl group is a substituent at alpha carbon. So this will also undergo type 1 reaction, to to give a preferential alpha bond cleavage. This will going to be a unsubstituted carbon, 2 hydrogen going to give a primary radical, whereas this is going to give a radical adjacent to the cyclopropane ring. So this is going to be a preferential cleavage, because this radical is going to be adjacent to the cyclopropane ring. We have already seen several examples of this type where these radical adjacent to the cyclopropane ring is going to be stabilized. So this is a carbon adjacent to cyclopropane ring is going to be stabilized, because this cyclopropane ring can be considered equivalent to a double bond, and hence this radical is going to be so this radical and is adjacent to cyclopropane ring can once again opens up to give a now one of the most important thing, which is because there is a substituent, there is one more cyclopropyl group is adjacent to this cyclopropyl group. So the opening of this cyclopropyl group is also going to be selective, because it will open up in such a way that the radical is adjacent to the cyclopropane ring. If we say, for example, this is the cyclopropane ring, this is the radical. If we cleave this, then we end up with the double bond, and then this is a cyclopropane ring, and then this radical is going to be after opening of this double bond, this radical is going to be on this way. But this radical is a 2 carbon away from the cyclopropane ring, is not adjacent to the cyclopropane. So this radical is not going to be stabilized by cyclopropane. So this is not going to cleave in this way. It cleaves in such a way that this radical is adjacent to the cyclopropane ring. So this will undergo preferential cleavage, and which is shown over here. So this is this radical, this bond cleaves to give a radical adjacent to cyclopropane ring, and then this will combine, this radical will combine to give this one of the product. There is also a possibility that this radical can once again involve in opening of this ring, but it has been found that, and it has been reported that this rearrangement, photoreaction of this particular compound is a 2 sequential alpha cleavage ring and cyclization. So this opening of the first cyclopropane ring to give a diradical, the combination of this diradical species into this give this as one of the products. Now in the presence of another photon, so that's why it causes 2 sequential alpha bond cleavage. So 2 photon reaction, this involves a 2 photonic reaction. One photon is involved in cleavage of this ring, and then to give this one on the initial product. Another photon is involved to cleavage of this ring to give this diradical species, and then this was again open up, involves in opening of the cyclopropane ring to give this radical. Here this is immaterial whether you open this side or this side, but first opening is very selective, because it will going to be this radical is not going to be stabilized, whereas this radical is going to be stabilized cyclopropane ring present adjacent to this. So this will once again combine to give this. So we can see here, as we have seen in the previous case, when the presence of the cyclopropane ring is a part of the ring system. Now we have a 2 cyclopropane ring. Now both the cyclopropane is a part of the macrocyclic system, and now we started with cyclohexanone with 2 cyclopropane ring to give a 12 carbon ring system, 12 carbon the ketone, 12 carbon cyclic ketone involving. So both the cyclopropyl rings are the part of the ring system after the rearrangement of via Norrish type 1 reaction. So this is a very interesting example where the cyclohexanone with the 2 cyclopropyl substituent at alpha carbon under photolytic condition undergo preferential cleavage to give a radical on the cyclopropane ring. Cyclopropane opens up preferentially to give another radical, which will combine to give one of the product. Here is a 9-membered ring system, and still one cyclopropane ring is a part. Under further photoreaction undergo further photoresist to give a via preferential alpha bond cleavage in the presence of light to give this, and then recombination to give this one of the product. Going further to the next example, here this is another example. Here we can see bicyclic system. This is alicyclic ketone under photolytic condition will also undergo type 1 reaction, is a alpha bond cleavage. Again it is going to be a preferential alpha bond cleavage, going to generate a tertiary radical. If we cleave this, is going to be a primary radical. So this will cleave here, and then this will undergo decarbonylation to give this diradical. This will combine to give this as one of the products. So 1,6,6 carbon system, carbonyl is lost along with the carbon as a CO, and then it will here have a 6,5 system of the photo reaction involving type 1 reaction. As we have mentioned earlier that the acyl radical also can also abstract an hydrogen atom from the adjacent methyl group. So this might abstract this to give a radical here after abstraction, and this will combine to give a double bond. So aldehydic ene reaction is, so the 2 types of products are reported in this particular case to give this reaction. So one is the decarbonylation product, other one is the aldehydic product by abstracting the hydrogen by the adjacent acyl radical and a double bond here. this acyl radical might abstract a hydrogen atom from here as well to generate a radical here, and then of course this is a radical here as well, and then this will combine to give. So there is also possibility that this may give this as one of the. So two aldehydic products are reported in this particular case by abstracting one hydrogen from here by acyl radical, and by abstracting one hydrogen from the adjacent methyl group by to give an aldehyde. This aldehyde, an ene reaction, this aldehyde with the ene reaction, and the exocyclic ring system, exocyclic double bond. Going further, this is the last example of this series. This is again a very so as we have mentioned that the in the case of alicyclic ketones, if the alpha carbon is substituted, the Norrish type 1 reaction undergo preferential cleavage to give you a more stable carbon sentinel radical. This will this undergoes loss of carbonyl, and then or acyl radical may also abstract a hydrogen atom to give an aldehyde derivative, and so on and so forth. So this is another example which have been studied here. You can see it is a bicyclic ring system. We have a 5-membered ring, and then we have a 1, 2, 3, 4, 5, 6, 7, 8 is a 8-membered ring here. So 5 and 8, 6, of course it is a ketone, alicyclic ketone. This will undergo under photolytic condition will go type 1 reaction. Here you can see there is a methyl group both the side, both alpha carbon. So you can cleave any of these. You can cleave either this or this, going to give the same similar stable carbon center radical. So if we cleave this radical, we end up with this diaretic acyl carbon center radical. This acyl radical may lose CO, carbon monoxide, to give a diaretical species. This will combine to give a cyclo 4 and 4 and a 7-membered ring system, right? Of course this goes the one carbon goes along with the carbon. It is also possible that this 4-membered ring may also opens up like this to give this as a also another one of the product in this particular case. So we have one product after decarbonylation and radical coupling, another second product after the opening of this cyclobutane ring, and then the third product is the abstraction of the hydrogen by acyl radical from the adjacent carbon. So this acyl radical can abstract a hydrogen atom from this to give a, and then this will form a double bond to give the enaldehyde. It is also possible that this acyl radical may also abstract this hydrogen to give a radical here, and then this radical can combine to give a double bond here. So if you write both the compound in a more decent way, so it is going to be an aldehyde, and then there is a methyl group on this carbon, and then there is a double bond, can be either on this carbon or on this carbon. So this can, depending upon which hydrogen is abstracted by the acyl radical, or we get a mixture of both the two, and that's why it can be both the aldehyde derivatives have been reported. So this is we have already seen different examples of Norrish type 1 reaction in alicyclic ketones in the previous lecture. These are the different examples where although the radical is more stable, but under certain circumstances radical is unstable, such as on the cyclopropene or double bond, and stable under on the adjacent to the cyclopropane ring. We have further seen few more examples here. These are all examples of Norrish type 1 reaction in alicyclic ketone, where preferential alpha bond cleavage followed by decarbonylation to give this product, or acyl radical may also abstract hydrogen atom from adjacent carbon to give enaldehyde. And we have also seen that the proper substituent on alpha carbon may lead to the ring expansion product, as we have seen here. If cyclopropyl group is a substituent, and after the rearrangement is the cyclopropyl is the part of the ring. And if this is the example where when we have a 2 cyclopropyl group is a part of the is a substituent, both come which both become the part of the ring system, and then it is a ring expansion macrocyclic ketone can be. So these compounds could be more synthetically important. So we stop here, and then we continue the next term. Thank you very much.